Example 11, for the circuit shown here, we have to determine the current I1, I2, and I. The potential and also the potential difference across the 6.7 ohm resistor. Okay, so we are gonna apply again the Kirchhoff's law. Okay, firstly we have to pick a junction. Okay, so let's pick a junction. So let's pick junction. I'll label this as junction A. Okay, so this is junction A. Okay, so remember the current, and then we have to draw the direction of the current. Okay, remember current flows from the positive to negative terminal. So this is, I'm drawing the current now. Okay, so this is the current, and then at this junction here it should go down lah, macam tu. Actually I'm gonna draw it aside there, sini lah. Okay, and then let's look at this one. So this one pula positive pergi negative terminal lah. So I'm gonna draw the current to be pointing to point A there. Okay. Yeah, so ini garisan dia macam ni lah, and then this one sepatutnya pergi sini, I1. Okay, so this is I1. Okay, yang ini akan sama dengan yang di sini. So this is I1. So this is I. This is I2, because this is I2 as well. Oh, lupa mo draw di sini. Boleh kah gitu aja? Okay, so this is I2 juga. Alright, okay, so now we've did the current punya direction, then we can apply the Kirchhoff first rule. Okay, so I'm gonna pick point A at point A, junction A. Okay, so remember current going in is equal to current going out. So current going in untuk point A is I1 dengan I2, because this going into junction A. So I1 plus I2 is equal to I lah, which is the one here, because it is going out of the junction. Okay, so this is our first equation. Alright, next we have to designate the direction of the loop. So there is 1, 2 loops. Okay, so there's 2 loops. Let me just draw it back because I think it's too messy. Okay, I'm just gonna draw the first loop dulu, yang ini dulu. Okay, so this is the resistor, then this is another resistor, then another resistor, then we have the cell here, the battery, the wire. Okay, so that is our first loop. Okay, so second we have to designate the direction of the loop. Okay, remember what did I say? I'll say that the direction of the loop should be following the EMF. Itu untuk saya lah, cara Miss buat. Okay, so I'm just gonna put a square so that you can see the direction of the loop. So this direction of the loop will be clockwise. Okay, so this is direction of the loop. Okay, then let me also draw the current. I'm gonna use a different color so that you can see it. Okay, so the current kita selalu lukis tadi. Ini current, then current. This is the current, then di sini. Okay, so ini loop number 1. Okay, also I'm gonna label it. So this is E1. Sorry. This is EMF 1. Okay, and then I'll call this one as I1 and R1. Okay, then this is I and this is R2, and then this one here is R3 and I1. Okay. Okay, now we can apply Kirchhoff's second rule untuk this loop here. Okay, remember Kirchhoff's second rule states that the summation of EMF is equal to the summation of the product of current and resistance. Okay? Alright, let's do this one. So this one, the EMF one is following the direction of the loop, so it is positive. Then it is equal to I1 here is following the direction, so it will be positive. And then let's look at this one. So the direction of the loop and direction of the current is similar, so it will be also positive. Plus lagi dengan, not plus yet, dating loop direction. So again, the direction of the loop is also similar to the direction of current, so it is positive I1R3. Okay, so from here, substitute lah 12 I1 3.9 I1 plus R2 is berapa? 1.2I plus R3 is 9.8 I1. Okay, bila kamu simplify it, you will get 13.7 I1 plus 1.2I equal to 12. So this is your equation number 2. Okay, alright, now we look at the second loop here. Sama juga, lukis juga, okay, supaya tidak confuse. Tapi kalau kamu tidak mau lukis, make sure kamu dapat tidak careless mistake lah, okay. So this is your cell. This is another resistor. Okay. Alright, so there's two resistors, one cell. Sorry, this one. Okay. Okay, now we are gonna draw firstly the EMF dulu lah. So EMF, I'll put it as gitu. And then I'll label it as EMF 2. Okay, so now the direction of the loop again depends on the EMF yang kita tinggal untuk that loop lah. So again, I'll put it as anti-clockwise sebab the direction of the EMF is anti-clockwise. Okay, so it's gonna be like this. It's easier for you to do this because you can actually directly see whether the current is following the direction of the loop or not. Okay, now we draw the current. So current is from positive to negative. It goes from here, and then it goes here, then it goes down here, then goes there. Okay, so this is our current I2. Okay, and then this is also I2, this is this is I2. Okay, boleh. What else? Oh, okay, I need to label them. So this one is berapa tadi? R2 lah. Okay, R2. So this is gonna be R4. Okay, now we can apply Kirchhoff's second rule. So let's see, EMF is in the same direction as the loop. So EMF 2 equal to, is it in the same direction? Yes, it is. So positive I2 R4. And then let's look at this one. So I is also in the same direction as the loop, so also positive I R2. And that's it for the second loop. Okay, and then let's substitute the values lah. 9 I2 is not given, sorry, so 6.7 I2 plus with 1.2 I. Okay, so that is your third equation. Okay, so now you can then solve the simultaneous equation where you should get I1 to be equal to 0.72 ampere, I2 equal to 1.03 ampere, and I equal to 1.75 ampere. Okay, yeah. So that one you solve it using your calculator and using simultaneous equation lah. Okay, you should get that. And then the potential difference, question B, the potential difference across 6.7 ohm resistors is given by V equal to I2R. Okay, boleh. So V is equal to V is equal to V yang kita cari. Okay, so I2 is equal to 1.03 and R is equal to 6.7. So V is equal to 6.9 volt. Okay, so that is the solution for example number 11. Okay, so it is not, this question is not difficult, except it's a tedious process lah. It's process dia banyak, the steps are banyak. Okay, so make sure you don't do any careless mistakes because it will cost you your marks lah kalau ada careless mistakes, right? Okay, so that is the solution for example number 11.